Awesome. Hello, everyone. Really excited to be here today. My name is Figo. I'm a research analyst here with IOSG Ventures. Really excited and really honored to be moderating this lineup. And yeah, for today's discussion, we'll be talking about ZK rollups, right? There are many kinds of rollups, but then is ZK rollup, how relevant is ZK rollup still? And will ZK rollup still be the endgame for layer 2? That is the question. So without further ado, I think we can start with like some brief introductions. Maybe each of you, it will be nice if you can share a little introduction about yourself, what you're building in the ZK space, and if any, how the work contributes to ZK rollups ecosystem specifically.
Yeah. I'm an engineer on the Noir Lang team at Aztec. We are trying to be the universal language of zero knowledge. And it's actually what Aztec is building its rollup in, but it's also a language that you can use for normal ZK apps as well, outside of the Aztec use case.
I'm Porter from the Matter Labs team, one of the core contributors to zkSync. zkSync now is a cluster of rollups. zkSync Arrow was our first one, and we're building the Elastic chain to connect everything together so we can have even more ZK rollups for the future.
Hello, everyone. I'm Michael from Brevis. So Brevis is not a ZK rollup. Instead, we are a ZK coprocessor. What a ZK coprocessor is instead of separating states and users and liquidity into a different blockchain ecosystem, we can actually scale blockchain by allow smart contract to offload complex and data-heavy computation to an off-chain environment. In this off-chain environment, you can generate the computation result, and at the same time, a ZK proof of the result itself. And then together with this, you can submit it back to the blockchain, so the blockchain can just cheaply verify the computation result directly on chain and use that result in an entirely trust-free way. So this is what coprocessor does. Specifically, Brevis allows a smart contract to be able to access historical on-chain data such as events, transactions, states, and do complex computation on top of them.
Hello, my name is Omer. I'm CEO, co-founder at Ingonyama, where we do hardware acceleration for zero-knowledge proofs. More accurately, we do software acceleration for ZKPs, for other people hardware at this point in time, but we are looking into hardware. We are very neutral, so basically we work with L2s, L1s, and anyone that has a need for faster, more performant zero-knowledge proof.
Wonderful. Thank you so much, everyone. So I guess we can get started with our first question. And I guess like something that we've always been wondering is like, currently we're seeing really different approaches to how ZK rollups emerge, right? Some focusing on EVM compatibility, others on maybe custom VMs, and others also kind of like varying approaches of proof generation itself. But the question is, what do you see as kind of like the key, I guess like technical differentiators, if any, that will matter the most for the sake of adoption? Maybe we can start with Omer.
Oh, okay. So first, as a disclaimer, I'm pretty sure that out of this panel, I know the least about what distinguish one rollup from another. So I can just give my own biased opinion and what excites me, right? So, and this is true for today. When I'm looking forward 2025, I think that privacy can be really interesting unlock, which today is still in the works, and there are some interesting solutions. I think that there is some mechanism design still left to do, at least when it comes to proving and how do you decentralize proving. By now, rollups, most of them, if not all of them, are centralized in many ways. And there are some very interesting ideas on how this mechanism design can work. Finally, I would say client-side proving, which goes together with privacy in a sense. But still, I think that if we can get the UX and performance for like a rollup to be acceptable, then this can be a huge win.
Yeah, I mean, there are definitely different flavors of ZK rollups with different trade-offs. and stuff. But in general, I just want to provide a broader view of like the blockchain design trade-off evolution path, right? So like why did we even have like ZK rollup in the first place? Well, because in the very beginning, when we were designing layer 1 blockchains, we only had 3 dimensions of rollup space to play with, right? So that is decentralization, scalability, and security. This is like well-known trilemma thing that we talked about like in 2017, 2018. So, the purpose of a rollup is to actually try to break this trilemma by introducing another dimension in the trade-off space, right? So like what we are introducing here using in rollup space is that we're introducing the trade-off of state and liquidity unification. So what I mean by that is, all these different rollups, ZK and optimistic, all included, they're trading off user liquidity. They're essentially, they're increasing the scalability by actually branching the state and the liquidity out from Ethereum, and at the same time creating unavoidably the liquidity fragmentation, user fragmentation, and the friction to move between different blockchains in the layer 2 ecosystem. So this is like kind of in a broad view of how different rollups came into existence, right? So now different rollups in this kind of a 4-dimensional trade-off space now choose different operating points. Like for example, different ZK flavors may choose different performance point and decentralization point and so on. But what we feel is very important is to look at what is the next step of the trade-off evolution, right? Because like even with the current 4-dimensional trade-off space, you still have very limited functionality and scalability on a single blockchain because it still operates as a single machine. On any blockchain, including layer 2s, you cannot be faster than a single server. So this is why in Brevis, we are actually introducing the 5th dimension in the trade-off space, which is synchrony, right? So we allow the you get the maximal
nodes running them to be like the more rollup obvious, like the more rollups we get.
What has been said so far, like probably converge to that looks similar. Is like this is the best. Actually, will differentiate these rollups. I think will be new use cases we haven't really seen yet. Interesting things that I think like ZK enables, and I don't think that purely focusing on scalability is going to be the differentiating factor for most rollups. I actually think for all rollups, there might be a few scalability winners, and after that, you're going to need something more interesting.
Awesome. Thank you so much for the answers. And I guess this is what makes this panel interesting, right? Because like, I guess like in the end of the day, like it's about ZK rollups, but then we have 2 ZK infra and then 2 actual ZK rollups here, giving like really wide range and really good answers. I guess this actually brings to the next question because like I know with ZK rollups has been building for I guess like a few years now, and quite recently also with seeing more and more maturing infra, I guess. Things that have been missing maybe in the past few years. This includes maybe proof markets or maybe like decentralized prover networks. So I guess like we're interested to know if there are, what do you think if there's still, if any, critical missing piece of infrastructure that we're still, I guess like we need to build, or maybe something that we already have but needs to be improved in any way. Yeah, and I guess for this one we can again start with Omer.
Okay, so I'm basically going to repeat my previous answer in different words. So 2 things. One, prover markets. I mean, we've been allocating some hardware resources to participate in experimentation of different networks, including ZK rollups, when they try to come up with some designs. And there are quite a few good ideas out there that needs more testing, needs more thorough research. I'm specifically super excited about this area, and I think we'll see some breakthroughs in the upcoming months. And that's definitely something I'm looking forward to. The other thing is performance. I've been I had this call last week with a AAA gaming company, and they are good guys. Like, they are hackers. They've been in the space for a long time. They have the money to build in like a game in Web3. And they're actually building, but when you ask them, so what's the plan? So they are just trying stuff and still do not have enough conviction that some like network or an L2 can can carry the TPS and performance that they need. I think it's wrong, right? I think it's more about education than anything else. Like performance-wise, we are already in a place where you can run a game, as we've seen some examples. But yeah, I mean, this is something that I mean, either like the education or, you know, let's keep pushing performance a bit more so that conviction would come, that needs to change. And I also very optimistic that it will happen in the short-term future.
Thanks.
Well, you know, for us, I think like, you know, one thing that we have been trying to build towards is like this off-chain verifiable computing future, right? So, you know, as I mentioned, for ZK coprocessor and in general, if you want to put something from a blockchain to an off-chain environment, you introduce the new design pattern of asynchronous computing. So you're basically not getting the answer in the same transaction, same function call. You know, that definitely will change how developers build applications and how they think about structure the architecture of the applications. You know, what we're trying to do, and I think this is still something that is missing, is try to build a framework that allows them to, you know, that essentially hide this kind of a complexity as much as possible and provide users and developers with an abstraction of synchrony. So they're still calling the same smart contract function, and the smart contract function is going to return the result almost, you know, in a synchronous way. So this way we can build, you know, tap into this type of infinite scalability and computation power without the complexity of asynchronous design pattern.
I think like as far as protocol goes, at least for like public ZK rollups, the sort of protocol design is fairly well understood, and I don't think there's too many more like redesigns of the entire protocol. It is just a lot of optimizations left, things like including hardware. I think apps can move to ZK coprocessors are like super underutilized still. So it's just kind of a lot of like speed ups and like making things like better and more optimal. We're rewriting our proof system again because more like I do think ZK as just like proving can still get so much faster, both software and hardware. But overall, I think like we're pretty close to the final state of what a public ZK rollup will look like.
Yeah, I tend to agree that the public state is kind of clear, at least the path. The private state, I would like to see more kind of in the client side proving, focus on how we can actually accelerate or improve those processes. It doesn't necessarily, now there's interesting ideas with MPC, TEE, FHE, maybe everything doesn't have to occur on a user's device, so it doesn't necessarily have to be purely client side, but a way that you can still maintain this privacy. I think that's going to be very interesting going forward, and that's one of the places where I think things are still missing. Right now it's still, everything happens on either your laptop or your phone. Phones have a very limited amount of memory. There's only so much you can compute. How can we actually expand that and expand what people can do in a private setting?
Awesome. Thank you so much for the answers, guys. And I guess other than infra and like I guess like this critical missing piece, one thing that will be really interesting to try to envision is the relationship between like the ZK rollup itself and the the underlying layer one, right? Like how, what do you guys think? Like, will we see rollups still become the primary settlement layer, where the L1's purely for like trust, if that makes sense?
Hard to predict, kind of speculative. Maybe. I do foresee a lot of people maybe would still want to use the L1 if you have a lot of money. Maybe you still don't trust the L2, at least especially in their current state. Mostly all centralized, or they are. So I think I could still see things happening on the L1, especially now there's a large push to still accelerate L1, so we'll see what happens in the future. Right now, I got to give the I don't know.
Yeah, I think people got way too carried away with, we need to move everything off the L1, everything needs to be in L2s. Like, that's not true. Like, the L1 should obviously still have, like, probably some of the biggest transactions. It's the safest. There are, still a lot of centralized pieces of the L2s right now. And so I think it was mostly just, like, a big crypto Twitter freak out of, like, overreacting, and that, like, the L1's going to be great. It's lots of cool pieces in the roadmap for it. and L2s will also succeed.
Yeah, I think I broadly definitely agree. Just one point to add there is that, I think all the blockchain workload is going to exist, like traditional asset-related, smart contract-related blockchain workload is still going to stay in the layer 2 and layer 1 ecosystem. But we do think that the entire blockchain ecosystem is like, what we have seen in the early kind of a web and internet evolution, moving towards this kind of a glue plus coprocessor model, where the blockchain infrastructure itself only acts as a glue to glue together many different specialized coprocessors, be that verifiable AI, be that TE, be that ZK coprocessor, to offload vast majority of the computation to these kind of a coprocessor architecture. This was what happened in the early 2000s when we had the internet evolution, because like back then, if you look at all the web servers, they were architected as a very monolithic server. Everything is a single piece of software, data handling, user registration, everything runs on a single server. But now quickly after the internet user explosion, we start to see the modern internet architecture evolve into a asynchronous and glue and coprocessor based architecture, where the web server become a very, very thin piece of software as a coordinator and the central connecting point to all these different specialized backend, like data handling services, machine learning services, and so on and so forth. I think Web3 is also going to go through the same evolution path. The blockchain, be that layer 1, layer 2, will still be very important, the coordination piece, but the vast majority of the computations can happen off-chain.
Yeah, I don't have much more to add. For me, L1 is Ethereum only, right? And I'm a good student of Vitalik, so I read what his blog posts about future roadmap of Ethereum. I think there is a ton to innovate, and you can't take this like route out. Like it has to be part of whatever future we are sketching. Other than that, yeah, whatever the other panelists said.
Wonderful. Yeah, I think I'm like, it's always nice to know, like, I guess like all the recent developments, like, how ZK Rollups is still, I guess, like, up there, thriving, and all, I guess, like new, little by little, all these further improvements to, I guess, like improving all the general experience from both developer side and user side of things. So I guess like, I think we can kind of like cut down to the final question here, right? Which is, so is ZKR still the endgame for layer 2? And I think my ultimate question for each of you panelists is like, what kind of like, I guess like milestone, or I guess like success case scenario that will convince you personally that, hey, ZKR is the end game for layer 2? And yeah, I guess we can start from Maxim.
Yes, once the optimistic rollups switch over to being ZK, in a way, like, yeah, if there wasn't like any demand for ZK, we're all kind of like fighting over nothing. So I do think it is the end game, but there might be, obviously there will be like large variations within that. And yeah, I think that'll be it. Once you see like these major rollups actually perhaps switch over, then you can kind of say like, yeah, ZK won.
That's fair.
I'm probably super biased, but I definitely think ZK is the end game. There's like, this is such a cool technology that you can like prove computation, and like I think it's going to be absolutely everywhere on the entire internet. Like almost everything, there's going to be a push to make it verifiable. Like overall in the world, people trust like less and less every day, and so I think like this is going to be completely massive, not just for L2s, but even like L1s will be ZK, like off-chain computation, ZK coprocessors will like process everything. Like I think ZK is going to literally be all over the internet.
Wow, that's very optimistic.
Yeah, I mean, like I think for rollups, the matrix that you evaluate, the quantitative matrix you evaluate is on the cost and latency trade-off, right? So like if we go back to the first principle, what is like the difference between ZK rollup versus like optimistic rollup? Well, ZK rollup gets you faster finality. What that means is that you can access the ZK rollup faster, like from liquidity and user perspective. Now, optimistic rollup, if you look at all the different bridges, it does carry a cost. If you look at all the bridges like connecting optimistic rollup, they are more expensive compared to ZK rollup today, but they're not that much expensive, right? So because ZK rollup in practice today still has a certain level of cost associated with to post proof on chain, and also like there's a latency involved to do aggregation, right? So what that means is that in practice, ZK rollup is not like a 12-second confirmation time. It's more like kind of a several hours, even 2 days, to actually exit a transaction from a layer 2 ZK rollup to the Ethereum underlying layer 1 blockchain. Now, I think that's going to change with a lot of amazing works that are being done in the both framework, theory, and acceleration space that will actually push us towards a tipping point where the cost difference, the liquidity cost of bridging between ZK rollups versus bridging between optimistic rollups is so apparent that now it's a very reasonable choice to actually kind of move to a ZK rollup based architecture simply because of the cost and better user experience there. So I think there's like kind of a tipping point there. But I do think that ZK is the future and also the end game here, because I think like we're working on ZK coprocessor to push most of the computation away from blockchain to this kind of a verifiable computing off-chain environment.
Right. So yeah, as a baseline, zero knowledge proofs, it's like a technology that was meant for a decentralized world, right? So it is a technology that allows you to deal with the situation that you don't have trust in the system and bridge this gap. So for me, it's definitely the end game for blockchains. Now, how do we get there and what are the tipping points? This is like a very interesting question. So what Maxim said about optimistic rollups adopting, I think this is something we're already seeing now in the process. It's not only them, it's also the rollup as a service companies. So basically these companies, they try to go for the low-hanging fruit in terms of engineering, right? Optimistic rollups are easier to, in terms of engineering. Don't hate me, but that's my point of view. And now you see that they also start to adopt and offer that. Another tipping point is to see what happens with ZK innovation with coprocessor, right? What Brevis is doing with zkML, for example. I mean, this is like, this is going to create demand. This is going to create actually use cases that for me, I just want like this experience and once I get it, once it's available, I'm just going to start to use it. So it's going to be very natural, kind of like milestone.
Cool. And I guess like maybe I can also add like from my point of view, if somebody asks me like OP versus ZK, I'm also on the ZK team, like for sure. Like I believe like ZK is the way to go, especially like since I guess like initially I think in the early days many people's concern was like I guess like it's computationally heavy, right? But then I don't think that's really gonna be a big problem. I guess like with how computation is just growing as stronger than ever, and I guess like ZK is we believe I guess the way to go, and yeah. So Omer, Michael, Porter, and Maxim, thank you so much for your time today. And yeah, have a nice day.